Good, how are you?
Any question? Let's start it with a question and answer session first. Any question?
I had a question for the GeoJSON for the term project,
Mm-hmm.
the GeoJSON visualizer.
Mm.
Did you want us to do it like with geographical locations on of the world? Like, could we do something like that? Or
No, it's an open question. You do whatever you want to do.
okay.
Okay.
But can we use if there's like a Python library called Folium that
You call library.
visualizes it?
You call library. That's fine. But key point is the idea of programming language. Okay, we welcome any kind of the project in programming language course, right?
Mm-hmm.
And we are teaching programming language pragmatic mechanism, okay? So what does this really mean? This really means that you need to provide some sort of language translation.
Okay.
So this GeoJSON project can work because you are translating your text to your visual data.
Okay.
So in a way, recently the most popular topic in CS is what? It's OpenAI, right? OpenAI, the chat GPT, right?
Oh, yeah.
Yeah. It's also a translation. You input something, you ask for something, you generate something, right? Some student may be
Join the meeting.
Maybe using the chat GPT to generate a program, right? I actually have no control on that. So basically, if you find some sort of language translation, that's good enough. For what application, children's drawing system, or you want to report any of the street address to the map, whatever you want to do, okay? We have no limit. It's up to you.
Okay, but if there was like a Python library that basically did the translating for you, turned that
I need
GeoJSON
I need you to at least finish the translation part. And
okay.
if you call some people's API, that's fine.
Okay.
Yes. Is that okay?
Okay, thanks.
Key point is you need to design something related to programming language. That means that you actually translate something. Programming language is to translate, say, Python to its pseudocode, or Python to bytecode, or actually Java to its a bytecode, or actually C double plus to machine code. Okay, some sort of translation, and that's fine. And you translate your input GeoJSON data to some sort of map. That's fine. Okay, some drawing knowledge is fine. Any other question? Just go ahead, okay? I'm fine. I'm fine. Any question? Yes, go ahead. Any question? Okay, I keep this open. Okay, so if you have any question about a homework project, whatever, is open for discussion. Bottom line is okay, I'm trying to teach this course, so the most important topic right now is this AI thing. Okay, AI things. People may lose job, even programmer may lose job. Okay, and we need to adapt ourselves to be able to handle the new AI age. Okay, new AI age. So how can you study to master AI? Okay, so in my opinion, there are a lot of computer science courses. Some are necessary, some are not necessary. So first thing is that you must own the programming skills. Okay, you must own programming skills. So programming skills say you need to know about C++, Python, Java, okay, at least the 4 language, JavaScript, website design. Okay, these are the basic programming skills. After these, you need to know about data structure. Okay, you need to know about algorithm. So basic computation, these two parts, I think, is the programming skill. Okay, after that, you need to know about this programming language, that's translation. And then if you can design your own compiler, that's actually good. Okay, this is actually CS courses. Okay, without operation system, without computer architecture, without any other language, without any other knowledge, these are core. Beyond this, I think you need to finish math, you need to finish the calculus. Okay, you need to finish multi-variable calculus. Okay, you need to finish the statistics. You need to finish the probability. Okay, and you need to finish the differential equation. Okay, these are actually lower division of the math department. Almost every single courses of them, you need to finish that. And you need to learn all these because, and statistics, okay, because you need to know about data science. Okay, the core of data science is something that you need to first know about it. And then second step, you need to learn math or machine learning. Okay, and next one you need to learn neural network. Okay, so these are the math package, and also including the optimization theory. So core CS knowledge, language translation, and then college math and the data science, math for machine learning and the neural network. Okay, these are something you need to equip. After that, you pretty much can be able to explore all of the AI fields. Okay, so these are what very important, and the programming language play a very important part, because a lot of it actually is a natural language processing. Right? If you learn AI, usually natural language processing is the first things that you need to learn in AI, right? Okay, any question? Anybody know where the room recording? Okay, room recording. Okay, let me see room recording. Room recording. Okay, every week we talk about this, and then you go to your course. So over here we have all of the recording for the past 6-7 years. It's over here. Okay, I may send out email, but sometimes I forget to send out email. So here, these are something you need to learn. Okay, you can learn from here. Okay, so usually I send out email, you may receive it. Okay, if not, you come to here, say this session is 2023 spring 003, so the previous 3 sessions are here. Okay, you can click the YouTube. Okay, you'll get the video recording. Okay. Okay, any other question? That actually is a good question. Okay, and if you are interested in the older semesters, so 2017, there are some whole collection. There's a playlist. You can jump to there. It's a whole playlist. And some different year, I may teach different materials. So some of the early years, we actually also teach the tool, some very important tools such as the compilation Bison and what's that? Flex. Okay, Flex and Bison. For the compiler, we actually teach it. The compiler Flex and Bison. Okay. So there are something before. 2023 Zoom recording. seem to be missing and hidden. No, it's actually there. It's not hidden. So anybody cannot access right now? Can somebody verify? Actually, 2023, you go to the side panel, go to the 003 session, side panel, and it's over here, right? It's over here. This is only for the class meeting. If you want to have the instructional material, you go to each week and instruction material. And then we have a recording here, and it's last year's recording, but it's over here. We don't reteach again, okay? Because this one, each one of them, I need to record it for 2-3 hours for each video. It's actually quite long. So you check every week's instructional material, okay? Well, how come you don't see? Okay, anybody here don't see it? What is the instructional material? Anybody don't see it? I have a student actually saying that he cannot see it. I don't know. Then, okay, you see the instruction material, then that's the lectures you have, okay? The previous 2023, no, there's 2023, this is the first session, so we do not have the fourth session. This is the first session we have. So some part we are still ongoing. So you can see 2022 if you want to have the older session. Okay. 2023, we just get started first right now. Okay. Okay. Anyway, you have to check by yourself. Okay. Any other question? Okay. Sorry, I take some chat problems. Okay. Okay, so that's actually continue. Okay, so a few courses I actually suggest. Okay, beyond your programming skill, a few courses that I actually suggest. Okay, you may like to get this one called IBM Data Science Certificate. Okay. This one, you may like to get it from Coursera. Okay, so this one is if you want to start a data science, this whole certificate, maybe 9 courses, maybe take you half a year, 5 months or so. This one is for first good data science certificate. Okay, and it will introduce you to the data science. So IBM Data Science Certificate. Second course I would strongly suggest is the Math for Machine Learning. This one is Coursera, Imperial College of London, and they have 3 major parts. One is linear algebra, one is multivariable calculus, and the third course is actually the principal component analysis. After these 3, you pretty much know what's machine learning. Okay, this one is very important. And then third course. So this one, second one is the math for the, and this is after data science, what you need for machine learning. Okay. And you can take other university courses, of course, but this actually give you some summarize, some introduction to it. Okay. Last one, I would suggest Andrew's deep learning for Andrew Moore. Okay. This course is pretty good. It's a good series of it, and you will go into the e-learning. Okay, e-learning with neural network and a lot of things. So after these 3 courses, I think you would be good in AI. Okay, and why we are talking about this is because what is okay overall. overall this open AI and then ChatGPT is what? This whole thing actually is an AI. AI will be equal to machine learning, okay, with compiler. If you know AI better, you will know that it's actually a compiler with machine learning. So basically, you do compilation, translate from something to another with the machine learning's assistance. That would be modern day AI and would be good for any of the natural language processing. So here I emphasize that you learn programming language is eventually a very important part in terms of later if you really want to work on the AI field, because you must master the compiler. An AI system is a compilation system with machine learning knowledge. Okay, that's what I define what AI is. Okay. Okay, so let's actually shortly talk about the importance of this course and why we teach programming language in this way. Okay, in the way we are right now. Okay, so this chapter 4, if there's no other question, I'm going to go over this one briefly, okay? Again, this one is 130 slices, so I cannot finish it, the whole thing in detail in 2 hours or even 3 hours. So you better look at the instructional materials parts. Okay, so my job right here is give you the idea what you are learning here, okay? Give you some guideline. And in the middle, if you do have some question or something, let me know, okay?
Professor,
yes.
I have a question. So I was working on my project 1 for the performance measurement, and while I was testing it, I found that some of the, like, say you have like 10,000 elements in an array, when
yes.
it takes a really long time. So
yes.
If you wanted us to screenshot the graphs before,
yes.
or you just want
you have to generate a pattern by yourself. Yes.
Yeah. So after we generate it, do you want us to screenshot it, or do you just want us to just?
I want you to give me the result using the PyLab matplotlib plot. Okay. I don't need the so-called screenshot.
Okay. All right.
You need to write a report because it's a project, but in terms of screenshot, let me show you. Okay. Let me show you. Let me actually bring up my Visual Studio Code. So you need to install in Python, you need to install your NumPy, SciPy, and matplotlib, okay? Let me give you something, okay? Let me give you a pacman file, okay? Let me give you a pacman file. One moment, okay? Oh, let's see, this one. Okay, I'm sorry. The Zoom set up by the university has some restrictions. I cannot directly access my file. So let me actually copy the text for you, okay? One moment. So there's a software installation for the Python. Here I do have, let me see one moment, okay. Matplotlib. Python, okay, let's see. Python PyLab installation, okay, this one. Okay, you need to install Python, this one, this whole package, okay? So if you install this whole package thing, it will include the NumPy, SciPy, matplotlib. actually also IPython, Jupyter, Pandas, Nonce, or whatever. Okay, these are a few things that you actually will install. It will be a complete mathematical package. Okay, so anyway, that's something you can install. Okay, so what I want is actually, let me actually create a new file. Sorry, the computer is slow. So let's assume here I'm in lecture 4. Okay, so I create a folder for lecture 4. So you need to install lots of package. And then here I'm going to create a simple.py. Okay, so here I do from pilot import start. Okay, and then right here actually I do have a equals linear space of 0. I'm sorry, 0 to 10,000, and then 10,000 or 1 point. B equals, okay, T square or T in A, okay, and then actually figure, okay, show, and then here plot A, B, green color, okay. So this one is a simple program, and I'm just showing you what kind of program I'm expecting. So basically, let's look at the A. A is a linear space sequence. Wait, how come it doesn't go out? T times, I'm sorry, this one should be T star, okay, square, I'm sorry. I used the wrong language, this is Python, okay, sorry, the wrong one more time. So this one is a very simple example. Okay, we are using PyLab. PyLab is NumPy, SciPy plus Matplotlib. Okay, so what I did is actually right here, I have a linear space from 0 to 10,000. From 0 to 10,000, they are totally 10,000 and 1 point because you have the 0. So 10,000 and 1 point, right? That's actually my X. I call it A, right? And my Y is actually any of the T in A using the comprehensive list. So I'm getting the T square for each T in A. So this is Y. So Y is f of X equals X squared. So for example, I finish such a plotting, and then I do figure plot show, and I get this. So I just need this. You do not need to send me the screenshot. So this screenshot I don't need. The tool will generate it for myself. Okay, if you don't have the package, then you go to this one to install this NumPy, SciPy, Matplotlib, SymPy, Pandas, whatever. It is the complete package that you need. Is that okay? And this one, after plotting here, if I want to save the figure, I can save it as a PNG, so there is no screenshot needed. It's actually portable network graphics. So the figure 1 can be saved directly to any of the disk location you assign. So there's no screenshot needed. The system provide you the Matplotlib graphing tools. Is that okay? And you can get that picture, and if you want to save it to put it in your Word document, or your PowerPoint document, you just save this one for it. And if you want to say zoom in, okay, you want to zoom in certain part or certain report, it's actually available. Okay, does that make sense?
Yes, it does. Thanks.
There's an inspector, so this is actually more convenient than you to try to use any or other tools. Just need to do that, and what you need is to install those packages I talk about here. Okay, but this is a good question. Okay, at least you ask for help in terms of tool. Other question?
Sorry, I have a question.
Yes.
Was it for the homework for this week? I mean, for next week?
Yeah.
The project one?
Project one, yes.
Okay, so we just have to, you don't need the picture of the graph actually.
I need you to give me the code.
The code, okay.
Yeah, so this code actually is also generated by the kind of graph I talk about.
Okay.
Yes.
So you mentioned as well,
but if in case that you really cannot install the tool that I talk about, right? And you decided to use Excel, I'm okay.
Okay,
I accept Excel if you if you are not able to use the tool I'm talking about here. I suggest to strongly review this one, but in case that you just cannot for some reason, okay, I don't know what's happening. Maybe your computer too slow, maybe you don't have a graphic card, or some reason that you actually just cannot make the product using the Matplotlib, okay? In that case, I accept Excel file. Is that fair?
Yeah, it is. My question is, for some reason, I don't know if we have to print out the list away that, for example, the first one was 10, 100. Do we have to print them out?
You need to print them out. I need you to show me, say, bubble sort like this, maybe selection sort like this, maybe different sorting, maybe like this.
Oh yeah, I'm not talking about the graph. I'm talking about directly on the console.
What console?
I mean, whenever on the editor, you know, when the list will show you what the random number will show, but you just want the graph, and then we explain.
This graph only involved with time.
Okay, you just explain. Okay.
We just need you to know. We just know about your number of elements versus the time. We do not need you to give me the random numbers. Actually, 2, 5, 7, 8, 19, usable. I don't need that. Okay, why should I need that? That actually.
Okay, yes, that's what I mean.
Just some numbers. Yes.
The other question that I have: do you need an explanation as well from the graph about the result?
It's a report. It's a report that you write. You can provide explanation if you have.
Okay.
Yes.
Okay.
This is a report. Report means a project report means that you do study, and then you learn something. You are welcome to put your whatever you learned there. Okay, but at least you need to include selections or insertions or bubbles or multisort crystal in there. These are the minimum that I need. This is a file sorting, yeah. Because I want you to go through every single sorting. Is that okay?
Yeah, I got it now.
Okay. And sample you need to generate by yourself. Okay. Some of the bigger sample size. You need to provide a non-recurring sample size. You can create using this something like what I did, a linear space data, right? And this one is the list of 0, 1, 2, 3, 4, 5, 6, 7, up to 10,000. And then you do shuffling. Shuffling, and then you will give you really random data in A, and then you do sorting again. Okay,
Yeah, I already almost done with the project. I just want to know about the report and stuff like that, and that's why yeah, I already almost done
Yeah,
with the
that's okay.
with the
That's
project.
okay. Yeah, I just explain in case that some people don't know. Okay. So a way to generate
Thank
a
you.
pattern, if I borrow this one, you can actually do copy, okay, paste. So this one, let's do it, call it sample, okay, sample. So basically, you can, let me rewrite it, okay, let's actually keep it as 100 data starting from 1. So don't start in from 101. So this one is a, and then I say A list equals list, converting the A space right there, right? So at this moment, I will get something called A list. So this A list is a list from 1 to 100, and then you do shuffling. I mean, you do shuffling the data, and then you would get a pretty random data, and then you do a sampling for it one more time. Okay, these are some data technique that you can use. Okay, this one actually is, if you have the question, you can just ask, okay? So now we are going back to this chapter 4. So chapter 1, 2, 3, we talk about the introduction of the language. So we pretty much finish the basic data type, and then lecture 4 is on imperative programming. So imperative programming is traditional programming, okay? So in early programming style paradigms, they are primarily imperative programming. Another one is called declarative. So this one is orders imperative, right? Orders. So it's instructions. So step 1 followed by step 2, followed by step 3, followed by step 4. That we call it the imperative programming. The other one is the declarative programming. That is usually logic programming, okay, list processing, so Lisp, okay, or anything that depends on schema, right, or data flow driven programming. It's not line by line programming. Okay, so this one is a different topic. So today we are focused on this imperative programming. Okay, but basically programming have different paradigm, and we actually think about we actually solving problem in different kind of paradigm. Okay. So programming paradigm, you have the imperative programming, and imperative programming, you have procedural programming, object-oriented programming, and parallel processing. Okay, and declarative, you have logical programming, functional programming, and database programming. And functional programming is becoming more important in AI. Object-oriented programming is also very important. And Python can combine both. Okay, Python can combine both. So this different language and their programming type, okay? And, okay, whatever. So your procedure would work on the data structures, okay, different data structures. And then, okay. And then what's the difference between your in procedural programming and object-oriented programming? Okay, so this is chapter 4 talking about overview of these. But we need to know about the difference between procedural programming and object-oriented programming. Okay. And object-oriented programming is also imperative programming. So the early days that people think about object-oriented programming is because that you want to actually encapsulate your data. So 4 things very important. Object-oriented programming is the encapsulation, inheritance, and the polymorphism. So when you are asked for the key feature of the object-oriented programming is these 3. So beyond the structural programming, object-oriented programming provide you encapsulation, inheritance, and polymorphism. These are 3 key elements in object-oriented programming, okay? And of course, all of these provide abstraction, okay? And we do use the object-oriented programming for quite a while since Java became popular in 1995. Okay, so far it's about 27 years of the Java language, okay? And because Java is the first web programming language, successful web programming language. Okay. So Java have been quite popular for a while. Okay, and until recently being challenged by AI paradigms. Okay, but that's why we need object-oriented programming. So object programming language beyond your line-by-line description of the code, you need to encapsulate your data into a object. Okay, so you do have the instance data field, instance method, static. You do have the class method and class functions. Okay, and class data. Okay, so this you need to learn OOP in Java well. Okay, so here we do beyond the object-oriented programming. Object-oriented programming also being extended to window programming, okay? And the mechanism is called event-driven programming. And event-driven programming become much more important, especially when the iPad, iPhone become popular. So event-driven programming become a mainstream programming beyond object-oriented programming. Event-driven programming is one kind of OOP, one kind of object-oriented programming. It just supports event mechanism. And you have the event source, event target, event handler, and event loop. And then using this whole event-driven mechanism to make your, say, touch screen possible, okay? To make your any of the screen gesture measurement possible. So right now, my screen is touch screen, so I can actually write any alpha, beta, gamma on it, right? My screen is a touch screen, and I also have my pen, stylus pen. If I need to use stylus pen, I do have my stylus pen. So these are event-driven programming, and basically, we started from the so-called structural programming. Structural programming give you the loop, give you the function, okay? Also give you the if then else, the selections, okay? That's the early days imperative programming. And then later it developed into object-oriented programming because you put those functions and data into objects and classes, and it manages the library. And then after that, you actually event-driven programming is using the OOP mechanism to make these events possible. Okay, so these are the relationship of these different paradigms. And some language like JavaScript has one single event loop. Okay, and some language like Java has multi-threading in the event handling part. Okay, there's something you need to know. So Java is a multi-threading environment, okay? There are many mechanisms that you can use, okay? And these are the, say, before 2020, before 2010, okay, before 2010. Before 2010, this object-oriented programming is the mainstream programming. After 2010, we started to look at the so-called functional programming. So we start to see the C double plus 11, C double plus 14, C double plus 17, C double plus 20. The newer C double plus standard start to put the functional programming into there. Okay. And then these are different functional programming thing being included to the C double plus. And Python as a AI language, Python also have the full-blown functional programming paradigm. Okay, and this functional programming, if you want to use Java to do it, is very difficult. It's comparatively more difficult. So we suggest to use Python to learn this functional programming. And if you need an acceleration, you choose C double plus. Okay, so you can actually look at the. You can look at the C double plus standards. And recently, there are many different versions. So C double plus is actually a monster, okay? But every 2-3 years, there's a major release being announced. More and more feature being added. And most important part right now, the addition is related to parallel processing and also the functional programming. Okay. So this is C double plus. Functional programming is not considered to be for the imperative programming. It actually is a feature of the declarative programming, but this actually is arguable. Okay, imperative programming, if you install the functional programming, is also possible. Okay, but in the old day, the functional programming's main idea is simpler, actually closer to what? Closer to Lisp. So you do have a function, right, and data, and then function, and then data. Okay, in terms of if you are actually in the Lisp language, you do using the function to processing on the data, and the result being put back to the list, and then there's a function processing the data. So basically, functional programming in the old day is a declarative programming. It's not functional programming, a pure imperative programming. But nowadays, the functional programming feature being brought into the so-called imperative programming. So it's also possible that you run it in C++ or Java. Okay, but the key idea is for the functional programming is that you actually compared to object-oriented programming is like usually your function, right? You have a function in Java. You take some data, say integer input. You get output maybe a double type, right? This is imperative programming, so function. Functional programming is different. Functional programming is that you do have a function, but your function can fit another function into it. And you can actually generate integer. Okay, and it's also possible your function, you do input function and generate a new function. Or you may have a function, you put integer and you generate a function. So functional programming makes programming with more and more different flavors. Okay, and the key purpose is that to shorten the computation time and the program design time. So here this simple chart give you the detail of the functional programming's basic features. When we are in the next chapter talking about the functional programming, we may go many of them. Okay, many of them, and this actually is functional programming. Okay, so we're going back to this imperative programming. This is traditional programming, so you may know most of them. Okay, so basically, computing divided into imperative programming and the declarative programming. So usually imperative programming is step by step, many side effects, okay? And you do have a variable that you can change. You can have a control flow. Declarative programming is similar to Lisp. So you do function, calling function, calling function, calling function, or logic rule, calling logic rule, calling logic rule. So basically, there's no side effect, no mutable variable. You basically don't store data. Your data output will become the input of another function. Okay, so these are the difference between the declarative and imperative programming. And imperative programming coming from the von Neumann machine using the so-called control unit RU and the memory. And basically, we also call von Neumann machine as C machine. Okay, so modern days computer, usually the CPU is designed for C, C++ purpose, especially C language. Okay, and all other programming language is on top of C. Okay. Okay, and then we do have a sequential programming. This one I think is okay. It just teach you the go-to branching, sequence, select, okay, whatever. These are basic idea. So I don't spend too much time on this, okay? This is just simple assembly language instructions and also the possible control flow. This is actually old days programming, just teach you how to do jump. Okay, you can study it. I don't spend too much time on this old stuff. And there's an instruction set. Okay. So nowadays there's a debate between using of a CISC, the x86 versus ARM array. And ARM has another challenger called RISC-V, RISC-V by Berkeley, right? So these are two war. One is actually using array processor. One is using the traditional x86 processor. So here you do see the AMD and you do see the Intel, right? But the GPU design and the CPU design, actually nowadays say Apple's M2, they move to ARM array, right? So they can have 192 core on the CPU. So nowadays, actually, the left side become more and more popular. I'm seeing that maybe within 5 years, the 6 will be dead. Okay, and everybody is just like M2 using the ARM core. Okay, and more than a few hundred of them, or using the RISC-V processor. So the paradigm shifting is going this way. Okay, so this assembly portion, we do see this. And nowadays, if you look at this OpenAI, OpenAI's core fundamentally still go back to GPU, still using a lot of array processing. So the company that benefit the most when the OpenAI or ChatGPT become more popular, I would say NVIDIA still may be the main company that would be driving it, okay? Is that okay? That actually is one of the company may benefit from there. So this portion, because this is a very old topic, we don't spend time on assembly, but when you need to know about assembly, usually is something you need to do acceleration, okay? So this portion, when you do study, you actually spend time on acceleration. Okay, and then the expression evaluation, this part are also very old topics, so I just go through it, okay? you need to learn the infix, postfix, and prefix translation. Okay, this is very important. We do have some homework working on this. Okay, we do have. Later you will see that. And the expression and operators. Okay, operators, there are many of them. If you do C language, there are tons of different operators compared to other languages, say Pascal or Fortran. These are fewer, okay, in terms of operators. So every language, the operators are different. I don't emphasize too much on here. Okay, these are just very traditional topic. This portion, I think, is fine. I don't want to waste your time on this simple topic. Okay. Okay, side effect. Okay, side effect. Side effect, sometimes you need to know about the design of the side effect. So say when you say if A equals 2, okay, so this equal is assignment. So you assign 2 to A, but some language like Java or C++, it do return 2. It return 2, but if you return 2 to Java language, and here you need to have a Boolean value. So Java language doesn't allow. But if this one is a C++ language, 2 means true. 0 means false. So then there is a side effect. If you write A equals 2 like this in C++, it actually will work. But if you write it in Java, it will not work. So be careful about the side effect of different languages, okay, when you go to the language. Several languages outlaw the side effect for functions, okay? And you have to be careful about the side effect, okay? And because there are too many, okay, too many. Usually the imperative programming languages do have some side effect, and those are declarative, no, functional programming, no, okay? But you do need to know about the side effect for different language. There are so many to remember, okay? And then subroutine, proc, okay, this one, okay. It's a basic structural programming. I think everybody know, okay? So this one, I don't emphasize it too much. Okay, and Python's loop, Python have while loop, for loop. And actually Python do not have a traditional for loop. Python only have the for each loop. Okay. And you have to use a for each loop in terms of for loop. And you have to use a while loop for do while loop. This is what Python you need to be careful. So Python's for loop is for x in A. Okay, A is any iterable object. Python's for loop is any iterable object. Iterable means that you can do counting 1, 2, 3 to generate it. You can actually pick up one by one. So at least a tuple, a string can be put over here. Any literable data structure can be put over here. It's actually different from traditional for loop. Okay, it's different from traditional for loop. But you need to be careful. Different languages for each loop mean different things. Okay. So say Java. Java do have enhanced loop. Enhanced for loop. Okay. So Java's enhanced for loop. You do for integer x from x list. Right? This is Java enhanced for loop. This is okay that actually in Java here, but it's a syntax. You have to declare it as integer. Okay, so here you have an element of the x taken from x list. X list can be array list, as long as it's actually iterable. Okay, this is Java's enhanced loop. But this one, when you go to Python is similar, but Python have no data type. Python is a dynamic type language. So basically you have for x in A, right? This one do not have to be integer. That depends on your A. Your A may have 1, 2, and then a list, and then A. So this X will be integer, list, and actually a character. It depends. As long as it's iterable, you will be able to take out different. So this is different. Okay, this actually, if you go to Python, it actually is different. Okay, and now if you go to the JavaScript, JavaScript is actually also different. So you actually for, okay, variable P, okay, and then actually in actually data. Okay, so this P, I use P because it's no longer a data type. It actually is a property. So this data is an object. So your data may have, say your data is an object and may have a P1, first property and some value, and a property 2 and some value. So it's for each property. It's no longer for each index or for each value. So JavaScript's enhanced loop is again different. So it's JavaScript for each loop is different from Python. And Python's for each loop also different from Java's for each loop. Now you need to be careful. Okay, when you study these 3 languages, the data type for each loop is different. And Python only support for each loop and the while loop. Okay, and Java supports these. Okay, so there's something that I want to say. Any questions so far? No question? And then the regular control structure, I think is fine. I think everybody know what loop is. So I don't waste my time to explain the detailed loop, okay? You guys are better than me, so this I can. Next one is iterable, iterators, and generators, okay? This is new concept. These are new concept and sometimes very confusing, okay? You must learn it. So usually you have a container or a container or a data structure, say array list. You do need to have some iterator, an iterator, iterable, and distributor are different. So to be short, to be very easy, using the simple concept to talk about it is like iterators are references. Iterators are pointers or references. It just used to point to somewhere. Okay, so no matter it's Java or Python, they do provide iterator. Okay, and in Java you need to implement iterator and iterable at the same time. A data structure is iterable. Say you have array list is iterable, and you will also have an iterator that you can be created and use the iterator to traverse to your data structure. So you do have the next function has next function and the remove function. These 3 functions are the basic function that the iterator have. And some iterator is double-ended 2 directions. So they provide the previous has previous and different other function. So iterator, to be short, is some sort of a pointer. okay, some sort of a pointer, and it actually will help you to traverse through your data structure. Okay, so these are the relationship. A generator is always a iterator. An iterator will make a data structure iterable. And iterable is a feature of a containers array list. So this chart is very important. Okay, let's do it again. You may have a container say list, and that list typically is iterable. And any iterable container will be able to use a iter to generate a iterator, and the iterator is a pointer. You can point it to any element in your container. And then generator is always one kind of iterator. You can use a generator function to generate generator, and generator is one kind of iterator. Is that okay? So if you want to know about the relationship between iterable, iterator, and generator, this chart is a golden chart for you to understand what these different terms are. Any question? And we pick Python because it's very complete in here. And in C++ also have all these. Java are very limited. Java do not have good generator, no, none of these. Java only iterator and iterable. Okay. So container is a data structure holding data. Okay, so you do have a set, list set, these are different things that we talk about. Okay, the brackets, the curly brace, and then parentheses and the double quotes. Okay, these are the containers we talk about. And iterable means that if your data structure can be listed, okay, using pointer one by one to point it, then you say that your data structure is iterable. So an iterable is any object, not necessarily a data structure, that can run an iterator. An iterator is a pointer, and you start to point it to certain data, right? And for each loop is actually using the iterator to traverse through your iterable containers. Okay, so you do have a list of 1, 2, 3. You create a new iterator from X. So Y is an iterator. Y is a pointer. So basically, this one build up a relationship of you have a container called X, and X has 1, 2, 3, and your Y is a pointer. Okay, so your next Y will get 1, and then next Y again, you get 2. So using the next function, you are moving your pointer. Does that make sense? Is that okay? Okay, any question? So iterator function, how you move iteration, if you use a double under function in a class, you would redefine the iterator. And the next function, same thing. Okay, these two functions are magic function in the class. Okay. Anybody has question about the magic function? No? Okay. Magic function is the some function that actually built in by the different object. Okay. So for each loop, your data must be iterable. Your X must be iterable. If your X don't have the iter function, you basically cannot get every element. So it is traverse through different next function to get the element until you actually finish. You don't get data. So that for each loop, you would have only support the iterable data type here. Okay, that's something you need to learn. Okay. Okay, and then that's about it. This one is to disassemble Python code for iterator. This one will relate to chapter 15. Our lecture 15, we talk about your iterator being disassembly to the Python virtual machine code. Okay, so here I don't go into the detail, but basically this is the detailed assembly code for the Python, okay, but we do not go detailed into there. Iterators are pointers. It's a function to find pointers. So when you have a next, you actually pointing to certain element in the list, then move on to the next one. Okay, that's the function of the next function is. Okay, whatever. This portion, they are also some circular iterator. So they are iter tools. Iter tool will give you the iterators, and they are traditional iterator and cycle iterators. Okay, anyway, you can look at that. Okay, we don't emphasize too much there. The next one is generator. Okay, generator actually is a special kind of iterator. So it's a iterator, but it's a special kind. Okay, a generator allows you to write iterator like a Fibonacci sequence. Okay, and using these functions. Okay, so basically it's actually a lazy factory. It's actually creating program. So let's look at this example. We do use the iterative function to import the islice. Okay, so we do have a Fibonacci function, previous and current, set to 0 and 1. So here we do while you EO current. Okay, EO current, it will be, this is a Fibonacci function will hold the data in some location. Okay, and then it calculates the next value. So here what happened is like, this one is a function, right? This one is a function. So when you do islice, this is a Fibonacci function from 0 to 10. You will use this function to generate a Fibonacci sequence for 10 elements. So this one, it looks like you don't have the return type, but this islice will run this 10 times and then hold those data into the list. And the list will be generated by the islice and being returned to here. Is that okay? EO is to hold in the data to some location. So you hold your current and your current update, and then next loop, you hold your current, but it say true means that you keep doing. But how many times? How many times depending on your islice? Your islice run 0 to 10, so it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So run up to the 10 times. Each of the holding value will be generated by the islice and being converted to list to here. Okay, so this one finished the Fibonacci function, but it doesn't. There is no return. Say return something. No, there's no. It's a holding to the current and being generated by the function. And so we call this Fibonacci function a generating function. Is that okay? Very confusing, but who is writing this? I don't suggest if you are not good in not doing the generating function. Okay, this is just that you know that there is a new things that you can do is using EO. Okay, using EO as a holding data in certain location. Any question? So generator is one kind of iterators. Iterator is implement for iterables. Okay. Here I just show you these are the newer things for traversal. Okay. Okay. Here we have the generators and comprehensive generator. These are more popular. You see that when I do the example, we do using the comprehensive list. That means that for every x in numbers, I'm going to put x squared in the tuple x. Right? This is comprehensive tuples. You can also use the x in numbers and then create x squared to create comprehensive list or comprehensive set or comprehensive dictionary. Dictionary, you use x and x squared. So key is x, value is x, time as key value pair. Okay. So these are using the comprehensive generators. This is very popular. Okay, this is actually very popular, very convenient and very popular when you need to create something like this. Okay. Okay. Anyway, there are some more things that you can look at. I don't waste time to talk about it. So generator access data in pieces, compute data in pieces. Okay. It will save memory because you do not need to list everything. You just need to use an equation. Okay. Use equation to generate it. And you know it, use it well, it will be very, very powerful. Okay. So generators are incredibly powerful programming structure. Okay, whatever. And then next one is the function. Okay, function. Let's see how much we still have. Okay, so function in the traditional language, it's just jump to somewhere and come back, right? And in Python actually is a object. Okay, it's actually also an object. So it's an object. So there are rules, there are subroutine, there are different things. So traditional subroutine, we don't emphasize it. You know it. Okay, so. But function, remember that the newer function, you can input function to generate function. You can input number to generate number. You can input number to generate function. You can input function to generate number. So function become more popular, more different type. Okay, and you do have function signature as a name and your parameter. And your parameter may have default value, may have grouping rule. Okay, and may have a return hint. Return hint is not necessary. It doesn't take effect. But nowadays, some people like to use return hint because sometimes, because Python is dynamic language, so they forget about the return type. But some people actually don't like return hint because they want the return type to become, to have different type, okay? And they are local variable, they are return statement, okay, whatever it is a function. And code stack, you need to understand code stack, but these are more general. Okay, this portion I just called. And exception is a special type of function that when program go wrong, you can use exception to handle your branches. Okay, so basically you need to know about when the exception problem will occur and how to create exception and how a exception can be handled. So exception handling, you do have try section, except section, and something like that. Okay, so try section is that if there is some error or something, you can raise the exception, and you will be handled by the except part. Okay. So this portion, I just briefly talk about it. If you do have a question later, let me know. Okay, it's exception handling. Recursion is a function that calling a function itself. Okay, this one is same as any recursion you know. Okay, so let me see. This part I don't waste time. And one thing that you need to know is that usually only tail recursion is effective enough. Okay, so tail recursion is that after your recursive call finish, you do not actually do extra computing. If you do extra computing, that's not tail recursion. Tail recursion means when you return, you directly return with a function call. Okay, that's tail recursion. And the advantage of a tail recursion is compiler can optimize it so it will be faster. Okay. So it will be faster. So there are two different ways of writing a GCD, quantity common denominator for M and N. Okay. Different way to write it. Tail recursive function. Okay. So here, if you have a function do recursive, but you need to have extra operation, this is not tail recursion. So compiler cannot optimize optimize this one. Okay. So tail recursive code, we use the subroutines frame on the runtime stack, so it actually has some benefit. Okay. And usually we suggest that if you need to write recursive function, always write tail recursive function. Okay, here just something that I would like to emphasize. Okay, and this GCD, we can also write it in a traditional way, non-recursive code using while loop. Okay, this is just for comparison. Okay, so basically, every recursive function can be written into the iterative way. Okay, so this Fibonacci function written in recursive form, this usually is a very inefficient way to do it. Okay, so it's only for the textbook to teach students that okay, Fibonacci function can be a example for recursive function, but in fact, Fibonacci function calculation by this is totally ineffective. It is an exponential time. Okay, so if I write it in using the while loop, this one is order of n. Compared to the Fibonacci function, this one is order of 2 to the power n. And why people keep talking about Fibonacci function in recursion? Just because it is actually can be used to explain a recursive function well. Okay, just because that for teaching purpose. But in real world, if you really want to calculate a Fibonacci function, please use the iterative function right in the while loop like this one. It's only an order of n. Because let's look at it, okay? You do have your, let's assume that your f0 equals 0, f1 equals 1, right? f2 equals f1 plus f0, right? So your f2 equals f1 plus f3 equal f2 plus f1. Okay, so basically, you just shift the data from here to here. And then this is 1 iteration, 2 iterations. So your fn will just need n iteration. If you use the while loop. Okay, if you use a while loop, you just go in this way. It's actually an order of n operation. Okay, but if you do use the recursive function call, if you do use your recursive function call, you do have f of 5, you call f of 4 plus f of 3. F of 3 is brought to f of 2 and f of 1, right? And this f of 4 equals f of 3 and 2. So this actually is an order of 2 to the power 2. Tau n exponential growth. So actually it's not really practical. Okay. And you do see some programming textbook teaching you to use a recursion for Fibonacci function just because that is actually a good example to explain Fibonacci function. Okay. Okay, next one you do have stack. Stack is to realize your local variables. Okay, how local variable being handled and return value. So this portion I don't emphasize it. I think everybody knows it. Okay, so it's used to do this. Okay, this one I think some people work on the homework. We do talk about epilogue and prologue. Okay, return is return value, but there is a procedure that handles the return value. That's called epilogue. There is a calling sequence that handles the function call. That's called prologue. Okay, so these are prologue and the epilogue means the procedure that used to handle the context switch. your memory code, your code frame, how you pick up your code frame, how you actually put those things in. So return is only part of the epilogue, one statement of the epilogue. Epilogue including your transfer of the control, also your elimination of the code frame, also something related to finish up a function call. So this is something to clean up your code frame. Your code frame, including parameter, local parameter, temporarily keep booking information, several different things. You need to completely have a good transfer between your one procedure to the other. That actually is called prologue or epilogue. Okay, and it's a prologue you write down as a prologue, OGUE. That's also okay. That's also okay. Epilogue, APILOGUE. That's also okay. Okay, so here to show you what prologue need to be done. Okay, all the tasks of the prologue and epilogue, what you need to be done. Okay, it's not just give you a value. That's it. Okay, it's not just that. And here we do have the detail of the register file. Okay, this portion I don't actually spend too much time. It's too detailed, just for you to understand in microprocessor what should be done. Okay, and here we do have the low-level virtual machine. That actually is a virtual machine for C++. Okay, for C language C++. Low-level virtual machine would make your processor become more powerful. So you may run the ARM processor's code on CISC or CISC on ARM processor. Okay, so you compile only to your low-level virtual machine, and low-level virtual machine will run on ARM core or run on your CISC core. So there's a trend to make C++ also portable using the low-level virtual machine. Okay, just like your Python, your Java using Java virtual machine. Okay, so there's a trend to compile the code to low-level virtual machine. So this is a proportion that how calling sequence is being handled in low-level virtual machine. Okay, that's it for this chapter. We basically talking about the control and operation of the imperative language. Okay, and we do talk about some detail, just making sure that these new feature you understand it. While you study, if you have question, you are welcome to let me know. Okay, any question? Okay, no question. That's it for today. Okay, any question? Okay, thank you. Bye now. Bye bye.